So you should see slides now.
Yeah.
Great. So when we talk about virtual research environments, we are also talking about science gateways and virtual labs. So virtual labs is the expression, the term which is more used in Australia, science gateways more in the US, virtual research environments in Europe.
And sorry, sorry, I keep interrupting you. I'm really sorry, Sandra. Would it be a good idea to just ask people to introduce themselves and say why they want to be here? Because I think I know everybody on the call, but you may not.
Okay, we can do that maybe after the introduction.
Oh yeah, okay.
Because I'm not going through all the slides, just only shortly about the terms and how we talk about it to make it clear. Okay, great. So yeah, if we look at research nowadays, there's really the need for these end-to-end solutions for accessing software, computational services, equipment, lab instruments, and really to help science and engineering disciplines for teaching and research. And we have this increased complexity of research questions, the hardware, the software, instruments, data volume, and data formats. That's all the topics listed here. And you see in the middle, the little bit sad looking Einstein. And to help with all this complexity and to make him, to make him happy, we are working with virtual research environments, science gateways, and virtual labs, so that he can really concentrate on his research questions or on education instead of dealing with the nitty-gritty details of infrastructure. So, and if we look at this elephant, yeah, if you look from different perspectives, you can describe it's very different, and therefore, yeah, the expression science gateways or virtual research environment, you might have heard about cyber infrastructure or research portals, virtual labs or collaboratories, where we are not clinging to an expression, but it's the concept behind that we really want to have these end-to-end solutions supporting research and education. So if we look, for example, at the VRE interest group, so we want to keep it as an RDA interest group, but we want to extract topics to build working groups in the future. So one of the ideas was towards a common reference architecture for VREs, really to look at topics which could be maybe worked on in sessions between the different plenaries with online sessions. And we look at building blocks. So if you look at the concept of Lego, there's all the same interoperability interfaces, and you can create really this beautiful architectures. And this is the idea also for VREs, that we have building blocks from different mature frameworks, and we have this concept that we can, in the future, have something like a plug-and-play architecture for different features and functionalities. So, and this is the end of my first part of the talk. And I stop sharing here. So that is roughly what we would like to talk about, but maybe now everyone introduce themselves. Maybe I start for people who don't know me. So I'm Sandra Gesing. I'm from the University of Notre Dame. I'm a associate research professor in computer science, and I'm in the topic science gateways for 14 years now. And you hear my accent. I'm not from the US, I'm in the US now. I'm from Germany. And I still tell everyone, but you are really lucky, because I lived also in Edinburgh. I worked for the University of Edinburgh. So I managed not to mingle the German accent with the Scottish accent. So you still can understand me, hopefully. So, and with this, I give it to the next. Kiran?
So I'm Kiran Dharmavan. I think I know most of the folks here. My background has been building research infrastructure for quite some time. Currently an independent consultant into the space. And yeah, involved in this. Got a special interest in architectures and being able to scale things up. And that's where my main interest comes into this space. All right, we might go with Andrew next.
So my name's Andrew Trelaw. I work for the Australian Research Data Commons. I am responsible for a theme looking at e-research platforms and software as a first-class research output. We've done a lot more on the first one of those things, and we're about to start doing more on the second one of those things. And in this context, I'm also co-chair of the Technical Advisory Board and was co-chair of the organizing committee for Plenary 15. So I'm joining this both because I'm interested in the topic, but also because I want to see how these virtual plenary sessions are going. Let me do what Kieran did to me. Kerry, would you like to go next?
Hi, thanks, Andrew. I'm Kerry Levitt. I work for ARDC as well. I'm based in Adelaide. I am, as of last week, the Platforms Program Manager. So Sandra, just to throw another term for Science Gateways, we are now calling them platforms. So we've got a program. We've recently invested in 10 new platforms, and we've got hopefully another open call out this year. So I'm very interested in this topic.
Okay, you get to pick a victim now, Kerry.
Yes, just everyone picks the next one.
Yeah, and you're muted.
Sorry, I'll throw to Guru.
Thanks, Kerry. I'm Siddharth Guru. I lead a data services analytical program in terrestrial ecosystem research network. So involved in building a data infrastructure and then the virtual labs for a couple of years. When I see the program and the reference architecture, I was interested in reference architecture for a long time when we started this process. So probably interested in this topic. That's why I joined the call.
Okay, so who are you going to pick on?
I will pick my colleague Gerhard.
Hey, good morning, everyone. My name is Gerhard Weiss. I'm with University of Queensland now, so Guru is my boss essentially now at Turn here in Australia. My background is I've worked on various virtual labs over the past 5-7 years, something like this, and I was mostly technical lead solutions architect of these systems. That's where my natural interest comes from for these kind of things. I couldn't help noticing there's a big overlap in what we built, what people are doing overseas as well. And so it would be good to bring things together and align things. Pascal?
Hello, everybody. So I'm Pascal from France, and I'm working on the Toulouse University. I'm working on open science solution. I have a background of computer science, and I have worked on European project for e-infrastructure for knowledge practice. So.
Great, thanks. So I think we went through all the participants.
Yeah.
So Kieran, would you like to share your screen and start with your portion of the slides? And if you say something, you are muted.
Sorry. I was just saying that I was going to try and do some justice to Jiming's and Keith's slides because they're not able to join today. But I'm not an expert in this space, but I'll try and do it some justice. And Sandra, if I miss anything, feel free to jump in and add to it. So what we wanted to do is just sort of look at a couple of the architectures that's already been thrown around in this space, and then come into having a discussion about what a common architecture might be and what we might want to do going forward. So with that, there's the VRE for ERC architecture that was developed in Europe under the Horizon 2020 work. And where's my slides move? Yeah, there you go. That was looking, there was a number of VREs that were pulled together, funded at the time, and as well as this piece of work to look at a common architecture for those ones that was going to help make them more interoperable, more reusable. At the heart of this architecture is the resource catalogs, and looking at how those resource catalogs can be used to find the resources. And there were sort of two models that were put up. One was a distributed model, and the other one was a centralized resource repository. And what they allowed the VREs to do is to find the research infrastructures and know what's there and then how to use them. The architecture, fairly straightforward, consists of 3 tiers. There's an application tier that's been described, an interoperability tier, and a resource access tier. Well, that's pretty self-explanatory on how that looks. It's a fairly common diagram you'll see everywhere. So, anything important there? Yeah. The architecture then goes into describing a number of key components that should be there. There's a system manager that looked at implementing the main functionalities in there. The metadata manager, as you'll see in the next slide, that forms part of the key sort of anchor points in there. It covers the management of metadata from a range of resources and allows that to be used by the others. There's Interoperability Manager, which is looking at how it interacts with the various research infrastructures, workflow managers. And one I found interesting was the Link Data Manager that's looking at how the data can be published and linked together in there. And of course, the security authorization access layer. Conceptually, again, this is the diagram that they've got for that. And from a technical architecture, it's broken up into microservices. So there's the description of each of those areas, what the components are inside that. And then looking at it from an implementation point of view.
Sorry, Kieran.
Sorry.
If you can just go back a slide, you may not be able to answer this because these are not your slides. But the EVREWS, that common component, do you know what that is?
EVRS.
EVREWS, it's in the metadata service.
I would assume WS stands for web service.
Okay. Yeah, that seems like a reasonable assumption. Thanks.
Yeah, I think it's web service. Yeah.
That would be web service by the looks of it. Yeah, because there's
okay, and the data model mapper, which shows up more than once, presumably that's the same component, just appearing in 2 different services.
Yes.
Yeah, I'm just trying to get a sense of how much they're actually reusing components across the overall system. That's all.
Yeah.
Oh, yeah. Okay, thanks.
I think the data modeler depends on that server. It's not an exact model. Mm-hmm. It's just the mapper is a service. With the data model,
piece of functionality.
The mapper is different. Yeah.
Yeah. Okay.
So they've then mapped it onto a SOA style architecture on how the components would link together. And this slide I couldn't understand, but I think it's trying to describe the various components fit in linking things together. But in a nutshell, that's what the VRE for EIC architecture describes. So it tries to describe the components that are there in a certain form. I think Sandra, you'll go with the next one, and what you'll see is that there's a couple of different, attempts at this one and different components, and looking at it in different ways. And from an Australian perspective, and guys jump in here, I don't believe we actually have any architectures that we've attempted around our virtual labs or any of those things. So when I looked around, the different virtual labs have different models that they've applied, architectures they've got, but we haven't really worked towards any sort of descriptive architectures in Australia. But I think the opportunity is there to do that.
So if you go to the next slide, only at the advantage. So this is a slide about which different VRE projects really use this architecture and the microservices. So these are examples for it. That means there are a lot of still also other mature frameworks and virtual research environment also in Europe who are using their own frameworks, but at least this was one of the framework that was reused several times. And these are examples for it, and which were not only part of the project, but also partners of the project or projects outside of this EU project, which is promising, that not everyone started to reinvent the wheel after VRE for EIC came out with this microservices and with this architecture. So if you go to the next slide, I think that is so there is this open architecture. It's really for web services with APIs. So you can put a GUI in front of the microservices, or you use APIs to use some of, let's say, for example, the workflow manager, or you want to use the metadata functionality. So that is meant with open architecture. It has the modularized design based on microservices. And really the metadata is focused around interoperability and automation. So I know that some of the metadata is really for the processes, because independent of the domains, because there's also work in process for domain areas, which is totally different work on metadata than really reflecting metadata for, let's say, a workflow manager. Because you go then really in the area like for earth sciences. So the project is also supporting metadata for different domains who want to jump into. Yeah, more details you can see at this URL. And if you stop, so are there any questions?
Yeah.
So Kiran, if you stop
sharing.
Sandra, one question which you may not be able to answer. This is an example of an architecture which was reverse engineered from a set of existing projects. So they had a set of European projects. They then looked at that to identify, okay, so what are the common elements, common components there? Do you know if they then re-engineered those projects to use that architecture?
So it was not reverse engineered.
Ah,
so
okay.
They looked at, from the beginning, the goal of the project was to do the architecture for different European projects. So they put a lot of work into defining these services. Of course, in the project were already people with a lot of experiences for virtual research environments. So they didn't start at zero. But this was really the goal of the project, to support partners and in the project, but also external partners who had the need to create a new virtual research environment to come up with something that is so modular and supporting that it can be used for several projects.
Okay, thank you.
Okay.
And one of the things, Andrew, that they had done was that they've taken the various VREs that were funded at the same time, and mapped it against those services as to, for each one, which services are needed and which ones are not needed. So again, going with the building block model, it allowed each of them to say, we need these 5 services, and some other ones are not important in this particular VRE.
Yeah, okay.
But so, Andrew, how you started it, so there is a paper, or we started in the US to look at reference architecture, really like looking at existing successful solutions. And in the US, the science gateways, which are really very successful, are the widely used complete frameworks. So I'm sure most of you have heard about Galaxy, HubZero, Open Science Framework, or the Global Data Portal. So these are complete solutions.
Yeah.
You can install them and you have your science gateway already. So, but there are also solutions like RESTful APIs and with support of multiple programming languages and different features and focus on different features like Apache Avata or the Agave platform, Tapis. And these are really building blocks. And developers can use them in a way that they build their own user interface on top of them.
Yeah.
Or you can look at Cypress. Cypress is a very successful on code phylogeny, science gateway on code phylogeny with more than 20,000 users. And it has a wonderful interface implementation where people start to reuse it. And some universities like Indiana University offer science gateways as really full solution with resources in the background, like as science gateways as a service, so that small teams, for example, can use the science gateways with resources, don't have to install it, don't have to maintain it themselves. So SciGap is one of the examples. And the lessons learned in the US is that the approaches should be technology agnostic, using standard APIs or web services or standard web technologies, or deliver a complete solution. These were the frameworks which got really mature and successful in a way that they have a big user community, that they were able to be sustainable, maintained over years. So, and often the community engagement is key in the very successful projects like Galaxy, for example.
Yeah.
So Galaxy is one of the science gateway frameworks which did really focus from the beginning on community engagement. And the picture I show here is, for example, HubZero instances worldwide, and it's really worldwide.
Yeah. Can you move or close the chat window, please?
Yes, I was not sure whether you all see it.
We do.
It's
yeah.
only for me in the way.
Good. All right. Thank you.
Sorry for that.
That's
I
okay.
Sometimes I'm not sure what Zoom is showing.
Yeah.
And so let me see. Why is it not move? So and we look now at in the paper at core capabilities of science gateways. So this approach to look at reference architecture is complementary to the one that Kieran presented. So we looked at from a level, not from the technical point, but what are the really common topics in science gateways. And so one was that the users have to be recognized by the system. It's authentication, authorization, group handling. So services, science gateway must be able to integrate services. So like tools, like data. There must be an organized user interaction into sessions. And that user interaction can be really also stored persistently to support reproducibility and fair principles. And one big topic for communities is often also the sharing of interactions. Not only data and workflows, for example, or tools, but really be interactive in a science gateway itself. So the goal is to support really the FAIR principles on science gateways, virtual research environments. Virtual labs have really this potential to deliver this. If the whole reference architecture is really set up sustainable and usable and with reproducibility features. So if you look at FAIR, definable, accessible, interoperable, and reusable, that is exactly what we need. And the core capabilities I listed before, that is what helps to achieve these goals. And so instead of having our layered diagram that we have seen before, we looked at it more, what are the different topics that has to be fulfilled? And there are services, like the operating services, as I mentioned, the authentication, authorization, but really session and sharing, and not the tools or workflows, but really more the handling, how to deal with users, with groups, how to integrate services. Then there is the community is one of the big attributes for a science gateway. For collaboration, to support them, to support their contributions, whatever they would like to integrate into a science gateway. Then there is a big topic of infrastructure behind science gateways, from distributed computing or distributed data sources, lab instruments, maybe different scales, and to broaden access to it. Integration is on the other thing, like we have seen on the one hand side, the web services, APIs, access to tools, but also then to workflows, to data. So integration is really important for science gateways, and the workspace. Workspace is how people normally work. It's like having their workbench or dashboard. So that something is accessible. They don't want to think about where their data is. So for example, let's say they are sharing data, a group shares data between Australia and the US. Normally the researcher themselves don't care whether the data lies in the US or in Australia, as long as they can work independent of the location with this. So they need the accessibility, and the user interface should be really tailored to their needs. So this is how we looked a little bit with this paper at the reference architecture, on purpose more on a higher level, knowing that it's important to go more on a technical level and into more details and more technology oriented, like the EU project has done it. And that's from me. So any questions about this? So was there anything, oh sorry, did I interrupt someone?
No, I don't think you did.
Okay. So yeah, one thing is what is really to come from this high level. I know it's always the details, which makes it, of course, more complex. How we have seen with the microservices already for the VRE for EAC, but that is exactly why we try to complement both models to say, okay, is there any aspect, for example, you think that we have overlooked? Something, if you look at your own examples where you say, we need for this reference architecture, there's a field that was not mentioned at all. Or do you think your own solutions or those solutions you are aiming for, you could map them to these reference architectures?
So Sandra, two things come to mind. It may be that they're included and I'm not seeing them. Okay, so thank you, Kieran, for posting in the diagram, because one of the questions I was going to ask was around workflow. And I suppose the reason I was going to ask about workflow is that is an overloaded term. I mean, many of the terms here are overloaded. sometimes when people say workflow, they mean how can I, as a user, connect a sequence of operations using something like Kepler, which Guru is familiar with from Coesra project he's been working on. Galaxy itself is a workflow engine. Taverna, there's a many workflow engines. So these are really designed as user-facing sequencing / orchestration solutions. The other way that people use workflow is more as an infrastructure piece. How do we orchestrate the microservices together to meet the needs of particular users? And so those two sometimes interact. You have a user requesting certain things, and that requires you to orchestrate stuff down at the infrastructure layer. In the Science Gateways conceptual architecture that you did, does that sit under integration? Does it sit under infrastructure? Is the user-facing element sitting under services? It just wasn't clear to me where that fitted.
So, sorry for interrupting.
No, that was the end, yeah.
So yeah, with the workflow, I'm totally with you. So therefore, I try to be very concrete when I talk about computational workflows, like something that is supported by Galaxy or by Taverna, that this is a computational workflow for me. So computational workflows are really part of the integration, like the tools that you can combine tools also into a computational workflow. Mm-hmm. So that was meant there, that everything that is like functionality for the research is a part of the integration. The workspace is then how the user works with it. So that means if we have these domain-centric user interfaces, it could be that one research domain, let's say in biology, they say, oh, what we want to see, for example, Galaxy is very successful in that space. And I think what was very clear that they can use it as a toolbox and connect these tools with each other. And it was a graphical user interface without being, let's say, fancy. So there are fantastic fancy user interfaces out there which are also widely used. But what made Galaxy so strong, I think, was this very easy step to drag and drop tools together. People that know that they use them in a computational workflow, but their personal workspace was really being able to start really with a drag and drop and with the button, this computational workflow. And that is the workspace. More like what is tailored to the community, what functions there. And in the infrastructure, yeah, a workflow engine is part of the has to be part of the infrastructure if we have a computational workflow. In the tools, then we need in the infrastructure also the workflow engine. We don't need the workflow engine in the infrastructure if we are just talking about workflows as a workspace, as the personal, let's say, space for the researchers who are saying, oh, I do these sequence of steps to do my research. For example, let's say looking first or uploading data, starting one tool, and then converting data on the next screen or looking at results. That doesn't have to be a computational workflow. That can be shown in the workspace itself. Mm-hmm. Does that make it clearer?
Yeah, thank you.
So for example, I also didn't mention in this graphic something like metadata. So metadata is definitely for something that would be also in the integration, but also in the infrastructure. And dependent on whether users can set domain-oriented metadata themselves, it might be something they need also directly in the workspace and not hidden behind the scene. Mm-hmm. So there is an overlap between these different topics. And I'm happy to discuss, by the way, also the terms. We tried to use these terms for these different concepts or attributes of science gateways. But I'm happy to have a discussion about that there should be different terms for the attributes we are describing here. If it's not clear, it was hard for us to find these terms, to be honest, and to agree on that this should now match what we think shows this attribute in a good way. So one of the ideas also for this meeting was like, so towards a reference architecture is the topic, but to really put it in single steps to say what kind of discussion would be helpful to have maybe between the plenary meetings, and to say, yes, we would like to have, for example, a working group working on terms, common terms, how we describe specific things in a reference architecture. Would that be something interesting to come to something that we really know we talk about the same things?
Yeah. So just adding to that statement there, one of the things that I was thinking here is that if you look at from an evolution point of view for these, 10 years ago or so, we started the concept of virtual labs or VREs. It's very novel, very new. So, all the countries, as we were doing our research programs, we started developing, they started experimenting with these ones. And by and large, we're here today. We've some of those experiments have worked. Some of those VREs are still here with us. Some have not. So there's in a sense, there's been a degree of natural selection of what works and what doesn't. We've now, probably in the last 5 years, and certainly in the current program, a lot of the effort is more about consolidation, maturing those things in there. And if you then continue that forwards, if you looked at it in many technologies, what you'll see is that you'll have a convergence of things. So we had the place where we did various experiments. We're now slowly starting to converge into the key areas that work, in the models that work in here. So I think the opportunity I see here is that while there's been efforts in Europe to look at common architectures and models like that, in Australia we've done a number of ones. We have a few architectures I guess we can draw out of the ones that are currently there and the ones that people are planning to move forwards with on how things are going to be and so on. But to then look at it as more as a global one and start to mature that as well. So I think that's the opportunity space I see, and that's where I see this as part of the RDA, which is a global organization, that there is value to be added in there. So with that, I think it's worth having an open discussion. And I'm surprised Guru hasn't jumped in yet.
Guru may not even be here. We can't see him.
Yes.
No, I'm here.
Hey, Guru. You got lots of books behind you now.
Yeah. So Sandra, I think one of the things, the reference architecture, they're good. So what is your experience in implementation of the reference architecture? So one of the things we would struggle is probably because most of our implementation will be on the OpenStack. A lot of the services are not available as a service, and then in our implementation of the OpenStack, some of the nodes are not harmonized as well. So that limits a fair bit of our implementation. What it drifts down to is more become like a custom implementation. So what is your experience, especially in the implementation of that reference architecture?
So in regard to the different underlying infrastructures?
Yeah, so so the implementation so building a solution based on the reference architecture.
So this reference architecture is more reverse engineered from the existing solution. So I can tell you how it works with Sub-Zero. I've worked in Europe with WSP grade for a long time. And there were always, to integrate different, let's say, batch systems, distributed systems, or cloud systems, there were kind of submitters which would connect to different submission systems, or which would connect in a way. So you could always go from a science gateway, let's say for Hub-Zero, for example. Hub-Zero supports different batch systems, but also Boeing as volunteer system, desktops. And so there is this one rotator which then really knows how to go to the different underlying systems. And I've seen this in different architectures in Galaxy. Galaxy does it the same way. You integrate one submitter, and in a certain way that's always the user interface only has to give the keyword what kind of batch system they want to use. So I think this really layered architecture is used this way. That the infrastructure that you can plug in different batch systems. Was that the question?
Yeah, so for example, in the Galaxy, so Airavata and everything is like a one solution. So basically, you do the orchestration, the searching. So it's a very specific application they do, run the things. We are interested in so basically a bit of a more customization than that. For example, we do the orchestration, probably using some messaging queue technology to bring a lot of applications, partly because that, it's very hard to push on a one solution, just like Galaxy. Okay, Galaxy is the one, everybody compose their solutions like that. So that's why, if somebody, run their, is already existing model, we should be able to bring that together as well. That is the one of the flexibility we need, especially in the European Union architecture. There was a service-oriented architecture. After that, they put us, the microservices, and then the design, and then this services-oriented architecture. Does that mean that the internal modular thing is a microservices, and then the overarching things runs on a communication hub? Is it like more as an hybrid implementation rather than like a complete service-oriented architecture?
So that would be the goal of such a reference architecture, because I think different systems have their different foci and strengths.
Yeah.
And let's take, for example, Hub-Zero. Hub-Zero is integrated with Pegasus. It can do workflows, but it's not generally made or good for workflows. It's very good in different aspects for integrating command line tools. Very easy. You can create fast, a really beautiful user interface. So that is the strength of Hub-Zero. What you can do, you can reuse their microservices. Because they constructed as RESTful APIs. They had to refactor it also. So they started 20 years ago. So that, believe me, it was not RESTful 20 years ago. So it had to be refactored. So, but that is the goal, to look at these different systems and say, oh, we think that there are 10, 15 solutions which are maturing and which have a good community. We don't need new ones, but then they have to be so open that we can do a plug and play, that there are these RESTful APIs, that you can reuse the services without having a big piece of work just to trying to use them. That is an advantage with the microservices of the EU model. So I think the mixture between microservices and RESTful APIs is something where we should aim as a community to be really interoperable in these different functions so that we can start. Maybe, for example, you are the expert for OpenStack. Great. If I could reuse your services in my Science Gateway for OpenStack and I give you maybe my services for Boink back, great. You know, if we speak the same API there, that I think should be the goal.
Yeah, and from a national point of view, that's one of the goals for the ARDC, the organization that I work for. We are significant investors in development of these new e-research platforms, and we would like to, in fact, we built into the call guidelines that we'd like people to reuse and adopt existing functionality rather than re-engineer it. So we have some levers that we can pull to hopefully drive more of this kind of behavior. And so I'm attracted to the idea of moving people towards RESTful APIs, moving people towards microservices, encouraging people to build components that then make it easier for people to layer functionality on top of that.
Yeah, and really, I think the other thing is, I like that you are looking also into the, and the other thing is, I know, I mean, I started with 20, earlier, also with computer science, and of course the first idea is, you know, you think you can do everything much smarter and nicer.
Yeah.
Everything that is existing because you just learned it and you're so on top of everything.
Yeah.
So I know it's hard. It's hard to tell them, no, believe me, there goes so much work into
this is why we have 200 different workflow systems, because everybody looked at what was there and said, I can do that better in a weekend.
Yeah, then they need 3 years for it and it's another solution.
Yeah, exactly.
So, and
I think that's why I was saying, Andrew, as well. At the time, that was probably not a bad idea. That was quick to do. Today, there was a maturity enough that it's quicker to just pick up one that's already there and reuse it. And that's all part of the maturity. And we'll see new technologies, new methods coming in, which will be a gain in that space. But there are other parts of it, components of it, that are much more mature that we should reuse. And continue to do so, and being able to map that and be able to give guidance to the new person who's walked in, who's trying to build something, rather than reinventing every piece in the wheel. Can look at what's mature, just use.
So for instance,
they're free to should actually continue to experiment, because that's where the innovation comes from as well.
Yeah, exactly. And so you're moving the innovation up the stack. So no one, I hope, would come in and say, oh, I'm going to start by writing my own operating system or my own relational database management system. You kind of assume those are givens, and then you say, okay, now I'm going to layer on top of that. So if we can provide more of these common services, then you can do the innovation right up at the top of the stack, rather than having to rebuild all those layers from the bottom.
Yeah,
I am totally with you there, because I think what is still often that, let's talk about, submission of jobs to different batch systems. Nobody should write that anymore or implement that. We have fantastic submitters for that. I mean, it's like, yes, different batch systems, different cloud systems. We have done that 100 times. It would be great if it's just accepted there are good building blocks for that. And it's probably, like, as you said, I really like the example with the databases and operating system. We probably have to come to the point to sell that, oh, if you have this database, you use this connector. If you have these batch system, use this connector. Maybe that is helpful for reference architecture, and then people can look for their niches.
Yeah.
But I think systems also need to be designed for that. For instance, Galaxy 8 years ago, it was kind of a big monolithic thing. And if it didn't work for you, you had to adapt it. So in our case, we considered Galaxy back then, but it was probably a 3 to 6 months job to adapt it for our users. Or it was 2 weeks to build something that just does what we need. That's kind of a bit of a trade-off. I think software tools are getting there. the big ones. But back then it was really difficult, and that's also one of the reasons why there are 200 workflow systems.
Yeah.
I mean, of course, the huger the systems and more complex, the more invest you have at the beginning. But I think it gets really better. I mean, I've set up a Galaxy instance like 5 years
It's a lot better now, yeah.
In a day, and connected it to the DoyleDem batch system. It's much better. Yeah. It was directly usable. So I think it gets better. And the other topic is, of course, the more functionality is there. Yes, maybe it's easy to create something in 2 weeks, but if you have the monitoring and really you have to check all the different options, because one of the things we had, at least in the Science Gateway area also, that people who started to use Science Gateway at the beginning thought like, oh, the Science Gateway is not working. No, the error message was not clear enough that maybe the cluster behind it was down. So there, that was a lot of learning effect also with the monitoring and error messages to the users to be clearer. Where is the problem? To communicate that well.
Yes, or ideally make it as obvious and easy to use as possible, to not put off users right from the beginning. Because if you're not able to build up a user community that is happy with the product or can just jump in and use it, then you're never going to build up a community to sustain your service.
Yeah. Absolutely.
Well, we're almost at the end of the time. I just wanted to ask, I mean, is there interest here to look at use this working interest group and maybe even set up a working group underneath this to look at pulling together a common reference architecture and what needs to be in it, even at a fairly high level to begin with?
So it would be something like, 2 or 3 meetings between the different plenaries, RDA plenaries, not overwhelming.
So if I can, 1 minute. So if I can switch hats and just reflect as a member of the Technical Advisory Board, if we're going to do this, we would need to be quite clear about what problem the working group is trying to solve.
Yes.
And 3 things. What problem is the working group trying to solve? Secondly, how is the proposed work plan going to address that? And thirdly, how does that relate to the mission of RDA? So I think if we could be clear on those things, then yes, I would support the creation of a working group. And sorry, having dropped that into the conversation, I'm now going to have to leave you. Good luck.
Thank you for joining.
That's
Andrew.
okay. Yeah, bye.
Thanks, see you.
Good to see you. Bye.
I might have a question as well. Would it make sense to add something or include something like a model of delivery? That's more from a point of view of who are building, deploying, looking after those kind of services. What will be the model of delivery? Is it some hosted service? Is it a tool you can just install, deploy in your own environment or in some cloud environment? It's something that would be really interesting in that kind of architecture as well, especially when it comes to big, large federated service tools and services.
Yeah, I agree with that. I think that would be really useful, especially for new virtual labs and platforms coming up.
So I think the implementation will be different for the cloud operating system than the HPC. I think the presentation looks like it was a very HPC centric. I may be completely wrong. And then it also depends on what kind of as a service available in the cloud infrastructure as well. So for example, if I build this on Amazon, that will look completely different from what I build in OpenStack, especially our Nectar OpenStack implementation.
And user access becomes very different as well.
Exactly, yeah. I think, especially from the Australian perspective, it would be useful to take the reference architecture and then see how it should look in the OpenStack And then probably that is the good point for the ARDC to see, okay, what are the as a service, infrastructure they should support to, implement that, the implementation. Because a lot of things now, one of the major challenges, especially from the Australian perspective, is, we build everything from scratch. It's an infrastructure as a service, everything from scratch, and then it's hard to make it a very interoperable thing. It depending on the skill set as well. So people like Gerhard, is pretty good in a fair bit of things, build a better solution than probably other person. They can band-aid it together. It's very hard to build like a common implementation.
Yeah, I was going to ask you how you think this would transfer to the Australian environment.
So I think the Australian environment, I think what they need to do is, build a, from an ARDC perspective, they should prescribe, okay, you should use the bit of an as a service. Most of the solution should be more as a cloud native. If you look at a lot of the virtual lab, they are the monolithic services running on a cloud infrastructure. It's like a client-server architecture running on a cloud infrastructure. So one of the fundamental things should be, okay, make this a cloud native solution, then you force them to use it as a service, a lot of the as a service model. Then they may come back, look, this is not available in ARDC, then ARDC has a priority to put that in an OpenStack implementation of that, make that available. So a classic example, ARDC very recently sent an email telling that, they are shutting down the data processing as a service. That is Apache Spark and then the Hadoop thing. So what can we do if we don't have that high processing thing? So basically all of us, deploy our own instance of the Apache Spark. That defeats the purpose of all this conversation, actually.
And there's the other side as well with shared infrastructure, where the infrastructure provider just allows only certain people onto their infrastructure.
Yeah. So
you can't really offer access to that services from a central platform or whatever to anybody who has access to the central tool, but you have to kind of flow through somehow whether this specific user can utilize that infrastructure or not.
Yeah. So what I think what Gerhard is telling, my interpretation is, so for example, all of us have our own login ID kind of a thing. We set up our own thing that can be run as a service at the RDC level.
I know we're running past time, but I also wanted to see if Pascal had anything to say. He's been quite quiet, and I wasn't sure if he's had a chance to say what he's got to say.
Pascal, if you say something, you are muted.
Sorry. Effectively, HPC, I wonder if you have made retro engineering over Galaxy, but also over HPC Center. Do you address the HPC Center? Do you manage to integrate HPC Center in your solution? Because currently in Open Science we have a gap between different community, and I think the difficulties of the architecture it is to fill the gap between the different communities, and the community of the calcul, the community of thematic community, and so on. So I think in your reference model, you need more layer, technical layer for addressing technical things in the hardware backbone, a kind of hardware backbone, and then you need to put several layers until the end user.
So it might have been not so clear, but yeah, we looked at HPC Center also at the different batch systems, but for HPC, for HTC. So then the solutions, there are a couple of solutions who can really deal well with it. That doesn't mean that they're already openly accessible in a way that you can use them as microservices or as APIs or web services. So I think that is still the step which is really missing. Like if I would probably ask Gerhard or Guru now, like, oh, can I use your OpenStack web services in my solution from the US? I need a microservice who's doing this. You probably would tell me, Sandra, oh, it can do OpenStack, but you need the whole system to work with it. I would assume, maybe I'm wrong. If it already is modular, fantastic. But I think it's a great start. And I think that is still slightly the problem, that the systems are not interoperable between each other. So it would be great to just be able, for example, to use a piece of Galaxy, the strength of Galaxy with workflows, for example, and I can submit it to Boeing via the submitter that is developed in HubZero. So that would be a goal of making the different mature solutions so open that we can exchange the different building blocks between them. I think that would be fantastic. And there is, yeah, Pascal, you're right, there's still a gap between a lot of solutions. And each solution has their strengths, the solutions which are mature and long time around and have a big community. There's a reason for that, yeah.
There is a data community, there is computer community, and so there is a lot of solution, and I think the first job to do it is to trying to map the reference model over several scenario, several existing solution, and trying to put these different solutions together, connected. So.
Yeah, that sounds great. So, yeah, I don't want to cut it off. I hope that every one of you is still fine, that we went a little bit over the time. And yeah, the goal would be, I hope you all put your names in the notes. Great. So we would contact you, and you can then sign up or not, and we look at possibilities, what we could discuss on a working group level, what is a good start, also with people who joined yesterday. So some of them were also interested in having yeah, a working group beneath the interest group on specific topics. So that would be our goal, to a little bit, yeah, get the topic more rolling. As nice as it is to have every half year the plenaries to get something done, needs a couple of more meetings between the plenaries, and not only a plenary. Okay, so any further questions or discussion topics you would like to mention?
Not from me. I just want to say thanks, Sandra. That was really great. I look forward to being involved more, and thanks to whoever's been taking notes. I think Kieran and Guru, perhaps.
Yes, thank you for that. As typical, I didn't take notes at all, of course. So, yeah, thanks for joining.
Yeah, well, thank you for joining. I just wanted to say, if you have any other thoughts afterwards, feel free to put it into the notes in there, so we can capture that and use it as we're thinking about how we progress this along.
Absolutely.
Yeah, thanks, Sandra. It was really useful. So, Kerry, with your new position, probably you can start the conversation at the platform level to have like a bit of a reference architecture kind of a thing.
Absolutely.
Otherwise, every implementation will go their own way.
Yes, I'm thinking I've got a lot of work to do, Guru. That's what I'm thinking coming out of this.
I'm not surprised.
Yeah, no, I'll be in
Kerry, I was
touch.
just going to say, I'd love to have a chat with you separately on this topic as well, with what ARDC is doing.
Yeah, absolutely, absolutely. Send me an email. We'll set something up.
Yeah, I'll give you a ping after Easter.
Great, thanks.
All right, thanks everybody.
Thank you.
Thank you.
Thank
Have a
you.
great day. Bye.
Bye.
Bye-bye.